Yes.
Which one, Anderson, is going to be the better or the worst?
The better will be management.
The better is going to be in management. Why?
Because I see at the end, the highest evaluation, he has 89, so it's better.
Only in
Between the
management.
no, he can be also good in statistics.
Is he going to be better in management or better in statistics?
It's gonna be better in statistics because he has 55, so this is a low grade starting.
So
I
in
got
his better performance, where would you put Anderson? And the reason that I have this is because looking at these numbers, and I don't want to see these numbers, I want to see what kind of judgment and decisions you would suggest me to do. And what I would like to know is if I have 4 people that they do the job and you evaluate all these 4 people, and not all of you give exactly the same evaluation. And your evaluation is not necessarily accurate. And usually if the professor gives me an F, I give him bad evaluation. If the professor gives me an A, I give him good evaluation. As a result, the evaluations have a problem. But they give also information. What I would like to know from here, and I don't want to see these numbers that way I give them. This is the way Mathematica understands them. I want to know something that is extremely important. In their worst performance, what do they do better and worse? And in their best performance, what do they perform the best? And I give them in different ways that this can be presented. Let me go on into this formality first. One way to do is, in all cases, I give ranges. And range is the lowest to the highest. Anderson, in every course, has a range. And Mathematica solves the problem in such a way that always the solution starts from the lowest range. So if I have Anderson, I would like to know something in clear, plain English. Anderson, in its good performance, is performing better where? And Anderson, in his worst performance, is performing good or bad where? In statistics, finance, and management, I have the range defined in exact way, lower and higher. For economics, I have the range defined differently. I have what is more or less expected as an average, and I may have a deviation from the average. Whenever I have these cases, that can be seen in 2 different ways. Look, for example, at what is happening here. And look, for example, of what is happening here. And I want you to tell me what you see and how you interpret, understand. What do you see?
okay. In the
Things
first,
have something in common and something different. What do they have in common?
They have in common the information that I see. For example, Anderson in Echo and Williams in management.
Okay, what do they have?
They have here an explicit information.
What is it?
So they are here we see that the information is stated. For example, we
What is
see
this 60?
60 is the lowest devaluation.
No. Isabel, where are you? Isabel.
Yeah, Professor, I'm confused right now too, to be honest.
I know, that's why I'm discussing it, and I want you to keep notes.
Yeah, I am.
It's nothing wrong to be confused, nothing wrong to not be clear. What is this 60 that you see it here? Any idea?
Is that his lowest test score?
Any idea? You see 60 here. What is this 60? Did you take statistics, Guy?
Yeah, I did. Sorry, I was just unmuting my computer.
Professor, is that like the range when you take the biggest number, subtract it from the lowest, and then you get a median?
More or less. This is saying that the average that he is performing on the average with 60 points, and we have only one average, and he is performing around to 60, and he goes below and above that performance by 5 points. So what do you have? You have symmetry. He is around 60 plus or minus. While for Anderson, in all other cases, you have only what is the lowest and what is the highest point. The lowest and the highest point here is given differently. You give it with what is the expected, 60, and how much can go lower and can go higher. But in all cases, you have ranges. And you define the lower case and the higher case. So if I want to know what actually is going on, I would take that information and I want to calculate for everybody and for all the courses what is going to be the lowest and the highest rate. And I want, based upon that, to say, okay, Anderson is good in what? And Isabel is going to tell me, Anderson is really good in management. And he is as good in management in finance. And in statistics, he is almost there. But in his bad performance, Anderson is not that good in management. And in his bad performance, he is really good in statistics. And finance is somewhere in between. And if I want to see what is happening here, this case is 60 minus 5, 55. And this is 60 plus 5, 65. This is 55. 55 is here. So you will say that Anderson is as bad in economics as it is in management. But Anderson is not that good in economics. 65. That's the lowest grade, the lower score of all. Anderson is really good in management, finance, and statistics. And I want that information to be presented, if you can do it, in a graphical terms. But what is important here is that this range is a symmetrical range. What is the difference here? Williams. Williams has a non-symmetrical range because the plus and minus from what is expected, the average, is different. It's not 5 and 5, is 2 and 5. The other more important thing is that this information here is coming from what we know in statistics as a bimodal distribution. And write that down. What do I want to have here? I want here, in that particular case, to make a comment. Why do I need to make a comment? Because after me, Paco is going to take over. And I want to know that this looks like a bimodal distribution. What is a bimodal? It has two different averages. One average is low, the other average is high. And because of that, I get an impression that this is a bimodal distribution. But also from the low, it goes below very little. From the high average, it goes much higher. And it is also a non-symmetrical distribution. In reality, not in classes, not in textbooks, in reality, that's more or less the case. In reality, we do not have symmetry, and we do not have everything in one average only. And this is what I wanted to get out of here. Smith has a regular case, like the three cases that we have in Anderson. What we know, we don't know much. The only thing we know is what is the lowest and what is the highest. But with the other two cases, we know something a little bit more, and that is important. Can I rewrite it differently? Yes, Isabel would say that I will rewrite this as 55 and this as 65. But now I lose the previous information that I had. And actually, when we want to do that, we define these ranges not because this is what we want, but because we use the statistics and the distribution to find out what is happening here. Same way here. I can define this as 43. And I can define this as 68. But if I have 43 and 68, I do not know that information that is coming to me in statistics. The only thing I know is what is the lowest and what is the highest. If I don't know it, I don't know it. This is out of my knowledge.
Professor,
Yes?
can you refresh me on what bimodal meant again? You said it meant it had two different what?
Bimodal is like writing a B letter, capital B. It has two curves, two averages. One is to the top and one is to the bottom. I have a class. My class, if it's bimodal, I have a group of students that are A and B students. And these guys are averaging grade around 3. And then I have another group of students that may be larger, smaller, the same with the others, that are C and D students. And these have average as a C minus. If I put them all together, the overall average becomes a B. But if I separate them into two subgroups, then I know better how I will manage it and what is happening. So this is what is happening with bimodal. In other words, we have two different groups to be in one. And I want to
And
see.
this is in the case of Williams, right?
And this is the case that we have here. Same thing we have with this guy here. This is also bimodal. You have one average on 63 and another average on 73, 10 points higher. And things are moving around that case. But as they move around that case, what is the important thing that I want to see here? This, from this low point, can go down 20%. If it goes down 20%, that is not subtracted, but multiplied by 0.08. And from the highest point can go up 5%. What do I have here? Exactly, I have what I had before. My distribution is not symmetrical. Why it's not symmetrical? Because the possibility of going down is much higher, 20%, than the possibility of going up, that is 5%. Is this clear? If I want to substitute this information with a given numbers, what can I do? Doesn't work. What can I do? It works. I take the numbers. What is 50.4? 50.4 is the 63 going down 20%. I take it and I can substitute it here. As you see, the number continues. I need to make a change. It does not make a big difference if I can make it simpler. What I see, most of the business students think that they're astrophysics, that too many decimal points matter. They don't. What is this? 73% going up 5 percent points. What is this? 76. Is this 76.6, 65? How do you want to do it? Depends upon you. It doesn't matter how you will do it. I will take it only the basic point. It can go from 73 to 76. But now, the only thing I know is the range, the lowest and the highest point of the range. I don't know more about the distribution that gives me that range. But if I know all that information, I know something that is extremely important. And when Gail is going to make a presentation in a PowerPoint, I don't want to see these ranges. I want to see how Gail understands and presents that to me. What do I want to see? I want to see what is the best place to put Anderson. And it's management and finance. And I want to see if I have someone else who is good in management and finance. And Myers is in management as good as Anderson. You see it? Myers in management, 89, is as good as Anderson. Would you put Myers into management? Jacqueline says, no, because Myers is perfect in economics. Do you have a problem? Jacqueline says, yes, because Smith is perfect in economics. And if you have two people that are perfect in one place and you need to select one, I want to know who is going to be selected and why. And I want to tell me what this information means. Would you prefer Smith or would you prefer Myers? And why?
Professor, I'm gonna try. Maybe I would prefer Smith because Myers will be better in economics than Smith.
Forget the other thing.
Okay.
Only based upon that, in economics, do you prefer Smith or Myers, and why? When we make decisions, and as we make one decision, we have other decisions made. Look at what happened today. Today we made a decision. What decision did we make today? Did we make a decision who is going to be the next BMCC president? Or we made a decision to fire and not have as a president Miss Wills? What happens today?
We have a new president, right?
We have a new president, but Dr. Wills wanted to be a new president too. But
well, the other president must have did something better than her, right?
Or maybe they didn't want her and they want to take a risk with someone else. But when we make a decision about one, automatically we make a decision about the other, and we call that duality in decisions. So the duality has to have an explanation. And I want you to focus on what you see here. You see Smith. Smith in economics ranks from 35 to 100. Myers in economics ranks from 76 to 100. Forget about everybody else. Who you would pick up for economics and why?
Myers.
For economics, I would
yeah.
If I was to compare Smith and Myers for economics, I would definitely pick Myers because his lowest average is much higher than Smith's.
Correct. In other words, you will see this number and you will say something is fishy here. Because there are people who give him good scores, but there are a lot of people that give him bad scores. You look at Smith not only with respect to economics, but with respect to everything else. Can you say something? Among all the four, Smith is doing the worst, and Smith is doing the best in economics. Is this feasible? Yes, because that's a perspective of people. Do you want to take it? Maybe, with a risk. Is this clear? And I don't want you to give me numbers. I want you to give me your perspective, your reading about numbers, the way that I would understand it. And as I look at all that stuff, I want you to think, and I want you to tell me, if you try to pick up each one of them for each one of the course, who is going to be picked with what is probability and why? This is what drives your decision. You know, guys, we have computers since the 80s, the 70s, the 40s with the big frames. We were making decisions like this for the last 3,000 years. How did we make it? With logic. And this is the logic I want you to be able to tell me. Among all the professors, who is worst in what? Smith is worst in economics. Who is best in what? Smith is best in economics, but also Myers is good in economics. Who is really bad? Myers is bad in management. You see this 35. You see this 35 here. Among all the numbers, this is the lowest number. So what you don't want to do? You don't want to put Smith or Myers in economics or in management. What do you have to do? To put someone in the best. Is Smith the best in economics? Yes, but that's a big range. If the computer tells you this is what you want, would you take it or you will interfere and not take what the computer tells you. And that is what I want you to be able to think. So when you have to think about this problem, I want you to think, organize your data, and talk about who is strong where and how you will deal with domino effects. What is a domino effect? What is a domino effect?
When you make one decision and it affects others in turn.
And this is what I want to know. This is what I want to know. What do I want to know? Anderson is good in management, is good in finance. He is not bad in statistics at his best, but is not as good in management and finance. This is what it drives your decision. I don't want you to tell me that these are coefficients. I don't want you to tell me that these are ranges. I don't want you to tell me that these are in the objective function. I want you to tell me what is the information you get from there and how you get it in such a way that with my common sense, I would understand. And if you tell me this is your solution, I will buy it. And that's the first thing I want you to tell me. Is it easy or difficult? And if Kadisa is doing it without computers, I want to take it with computers, but I want to take it with computers with explanation. Is this clear? Then I go to what Esther and Robert were talking after that. Same way. I want to focus on this area here. I'm going to make it large in such a way that we would exclude everything else and not messed up with anything else. This is what I want to focus. Now you see only courses, right? What do you see? What are the courses that you have to offer? I don't want you to copy and paste that because that's completely irrelevant and not useful for me. I want you to tell me what these numbers actually mean. And these numbers mean exactly the same that the previous numbers meant. These numbers give you ranges. Why? Because Mathematica wants it as a range. And these numbers give you ranges in different ways. And I want you to know the background of your information. This range for economics is explicit range, from the lowest to the highest. And what does this mean? So Marie, what did you say about it? You couldn't hear me.
Is this in terms of?
Do you hear me clear now?
Oh yes, we can hear you.
Okay. So what is this range? This range is explicit, from lower to higher. And this range is not explicit. And this range is not explicit. And this range is not explicit. Is any similarities between these ranges? I will go on and I will put them in different order. Is anything that is different between statistics and finance? And this is what I want to hear. between statistics and finance is anything that is different? And is anything that is similar? How do you...
Professor.
I'm listening, Esther.
So as I see here, like we were talking before, we see a bimodal distribution and not symmetrical.
Where
In the
do you
case,
see the bimodal distribution?
for example, in finance, I see that the -2
In
is
finance, is this a bimodal distribution?
no here yes
Bimodal. Let's go on and clarify it so Eliza would remember. Bimodal is when I have two different averages, two different means. If the average is the same, it's not a bimodal. And in that case, I do not have anything that is bimodal. This is explicit. Do I have an average here? Or can I rewrite that information in a similar way that I rewrote this one? Damien, can I rewrite this information in a similar way that I have it here?
Yes,
an average and a variation. Can I do it?
Yes, Professor.
Good. Damien is going to say, my average is 2. It can go 1 point down. And my average is 2. It can go 1 point up. Damien has exactly the same information he had before. But now he gives it in a way that I know a little bit more about it. What is the average and what is the variability? Is this clear? What is the difference between economics and statistics? What is different between economics and statistics? What is different between economics, statistics, and finance? And what is the same? In all cases, I want to offer 2 courses. The average is the same, 2 courses. But here, Eliza would say it's asymmetrical. I will go down as I will go up from the average exactly the same. Right, Eliza? But here...
Yeah, so wait, I'm sorry, just for clarification. In terms of being symmetrical, it only requires the -1 or the +1, not the +2 or the other +2, right?
Symmetrical means you go down.
The variations?
Symmetrical means you go down as much as you go up. Non-symmetrical means you can go down less, but you can go up more. I didn't hear you.
I'm sorry. In terms of the bimodal, just again to clarify.
This is not bimodal.
No, I understand. That's symmetrical. In terms of the bimodal, just for clarification, that's going to be where the comma separates each of the 2 minus 1.
This is bimodal.
I understand. Can I finish really quick?
Yeah.
Okay, so where the comma separates, in for example, statistics, 2 minus 1 and 3 plus 2, those separate little things have to be equal in order to be bimodal, correct?
In order to be bimodal, this one and this one needs to be different.
Different, okay.
If they are different, then it's bimodal. If it's the same, it is one mode, one average.
And you said that 3 is the average, and then the other one is the variation, right?
Exactly.
Okay, gotcha.
But if you go up and down the same, that means that you are symmetrical.
Yes,
if you go down less and up more, that's not symmetrical.
Yes, sir.
If you go down more but up less, that's non-symmetrical. And then Gary here is going to say, hey, professor, I have a problem. What is this? Gary, what is this?
Professor, are you talking to me?
We don't have anyone Gary in the class.
Okay, I'm not understanding fully if you're saying Gary or Jerry. Yeah.
Gary.
So going back to your question, what was it? Sorry.
Finance. What does this mean?
Finance. Well, the rating for finance are the lowest are 0 because it negates 2 minus 2, and then the highest score is a 3.
Good. And this means what?
Well, it can be interpreted that he might not have been graded or evaluated at the lowest, or probably he doing really, really bad.
No.
Or only 3 students have.
No.
Okay, never mind.
What is the meaning of these 44 ranges? Eliza.
Sure.
What is the meaning of this equation?
The assignment of the professor to the classroom.
No. Is this supply or demand specifications?
This is the demand.
The demand. Demand of what? Of professors or the supply of classes?
I believe the demand of. Wait, I think it's the supply of classes.
You are right.
Okay.
This is the supply of classes. All of that stuff tells you what are the lowest and what are the highest possibilities of classes that you have to offer. If I want to put it in a very specific way, I will put it in a more simple way. 2 minus 1 is 1. 2 minus 1 is 1. 3 multiplied by this is what? What is this? Erica, what is
1.2.
this? What is this? Erica.
0.2.
No, it's not 0.2.
1.2.
What is this?
Oh, 0 is 0.
I don't want the answer. I want you to tell me what is this.
0.4.
And what does this mean? If I multiply something by 0.4, what do I do? I decrease the 3. I decrease the 3 by what?
60%.
Good. Gary is getting an A. I have 3 and I multiply it by 40%, which means I allow 60% decline. That means that I can go to as low as 1.2 or 1. Gary said, I can go to 1. Management can go up to 1. And 3 goes up this much. What does this mean?
25%.
It can go up from 3, 25%. It gets up to that, and Gary needs to make a decision. For Gary, this is 3 or this is 4?
I will round it out to 4.
And it's up to you to tell me what you can do it. If you can put it like 3 or like 4, you get different results. If you round like to 4, you will have it here. And 3 plus 2 is 5. And 3 plus 1 is 3. And after you have done all that work, I want you to tell me what is important and what I want to know. what are the lowest amount of classes I need, and what is the maximum amount of classes I need. And the only thing that I want to know is, you can go with not having any finance class. The lowest amount of classes that you can have are 3 classes. The highest amount of classes that you will have is 15 classes. And you can go from 3 to 15. And this is what you really need to do. Yes, Esther, question.
Oh no, Professor, I don't have questions.
You don't have questions. Yesterday, I received a note. All the classes we offer for Management 200 are packed. We opened 2 new sections today. If we open 2 new sections today, we need to find out professors to teach them and places to have them. And if they're going to be online, how they're going to be online. But this is what is important. What did I ask Eliza? What are these things? And Eliza said, these are the supply of classes I have to deal with. Clear? What is the supply? Something that is defined with a range. And I have a tricky question. Can Mathematica deal with ranges differently? In other words, if Eliza puts them like this, and if Esther puts them exactly the opposite way, and if Isabel mixes them up, does it make any difference or not? Does it make any difference or not?
Yes.
Yes, sir.
And if you know your stuff, you will know that makes a difference and how you will be able to deal with it. And this is what I want you to find out. And I will make a clear-cut distinction between someone who is methodical and someone who is not methodical and sloppy. Because if you have them like this, what is going to happen if you solve the Mathematica? You can have a solution. The question is, do you know how to deal with it? And if I was doing the work for someone else, I would leave it like this, so the other person will be screwed up. And if that person is going to be my boss and doesn't treat me well, I'm not going to treat him well either. And if that person is treating me really well, I'm going to put a lot of notes here so they will know how to use it. But I will leave it like this because I want to go at the end and see what is happening with the solution. Is it clear? Can we move on? I move on.
Professor, question.
Yes, sir.
How can we distinguish that, what you're showing us on the screen, versus what you were showing us earlier, which was rating the classes, that, these numbers versus the other one? How can we kind of distinguish in the sense that as in what they refer to?
All of the numbers are indicated the range.
No, I get that. But one is rating the professors, and the other one is
This is the rating of professors.
exactly. But where does it signify
This is
that?
the needs I have to offer a class, or how I will offer the class, or how it's going to be the supply of class.
No,
Class is good to offer.
I get that, but for somebody who just started seeing this screen, how would they distinguish there? Like, how they will interpret the numbers without having any guidance to say, oh, this is the grading for the classes, this is the supply of classes you have.
You cannot. You
Oh,
cannot.
okay.
That's why you go for education. That's why you are in a class. That's why you pick up a given professor and another professor, or a given software and another software. The training means difference. And we go to the last part. What is the last part here? Gary. What is here? Gary, push the button.
I'm sorry. What I'm saying was the number of classes they can teach.
This is the demand of every professor wants to teach.
And I'm just guessing, so I don't know if I'm going this direction.
That says that every professor can teach up to 3 classes.
Okay.
But while William, Sanderson, and Smith, they can teach at least 1 class, the lowest is 1 class, Myers wants to teach at least 2 classes. So here what you have is what is going to happen if we have a variation. And this is something that it changes. And let's make a change. We can say that Smith is happy if he doesn't teach anything. But if there is a need, he can go on and he can teach up to 4 classes. Clear? And then I have to balance things. I have to balance. If I look at the lowest, I have 4 people available to teach 4 classes. But Smith prefers not to teach anything. Myers would like to teach 2 as the lowest requirement. If you go on to the highest, you have 13 classes to be offered. 13 in the highest. You go on and you see what is happening here with respect to classes. Now we messed up the case here, right? Yeah?
Now, if we keep in mind the ranges go from lowest to higher, so you kind of, I would say, identify the number if they make sense.
You're right. That's why I want to make things up to see what is going to happen. Mathematica is doing only maths. Mathematica does not have brains. You have brains. What is happening here? I do not have the same order of the ranges. I have ranges that they start from high to low and from low to high. Clear? So what do I want you to pay attention? I want you to pay attention to economics and finance. What is happening here? What else do you have? You have a non-balanced situation. The classes that you offer to the people that they want to do are different people. And I want to go on and solve the problem. These are my calculations that I did in the process. I don't need them. What I have to do, I have to solve the problem. Is the problem solved? No. Is the problem solved? What do you do? Is the problem solved? What do you do?
No, it's not solved. I think you'd have to go back.
Leave everybody here and start paying attention to what is happening with the classes that we want to offer. And I want you to play. I didn't see you playing. You gave me what is the problem. What do you see here? Mathematica always starts with a position that you say start from that point. What did you do? You said Mathematica start from giving 3 and go to the lowest point for economics. You give 3 and go to the lowest point in finance. What do I want you to learn? the solution here comes to the lowest value. You go on to the problem, and as you have the problem in all cases, you have the problem in all cases here. You want to see what is happening with how you defined your cases. If you put this is 1 and this is 3, and if you put this is 0 and this is 3, this is 3, and you solve it, now you have a solution. You go on and see what is happening, and you see what is going on. One course in mathematics, economics, one course in statistics, no courses in finance, and one course in management are offered. I want to know what is the solution. And the solution is clear. It's here. Anderson is teaching statistics. Williams is teaching management. Nobody is teaching economics. Myers is teaching 2 economics. This is what I have. Why Myers is teaching 2 is my question. Why Myers is teaching 2 economics. Here I have 1. Can I go on and put more courses in economics? Here I don't have a solution. Here I have a solution. I go on and I go on. Myers is teaching 2 economics. Now it's 2. If I have more, I don't have a solution. Why don't I have a solution? And I want you to play. I don't want you only to tell me what is the problem. I want you to play. Because if you don't play, you don't get it. What is happening? I want to see what is the information here. This is the supply of the professors. If Smith can go on and teach 3 classes, there is a case here. Who is teaching what? We have it on that case. Anderson is teaching statistics. Williams is teaching statistics. Do I need 2 statistics? And why do I have 2 statistics? Here I said, statistics I want 1. Why do I have 2 statistics? What is other solution? We have 2 economics. Who is teaching management? Smith is teaching management. Why do we have this case? And what is that? This is a relationship between unbalanced situation when things may change. And I want to see what may change. What may change is what is happening with their performance. If their performance are increasing, do I have the same solution or different solution? If everybody is at the highest performance, I go on and I have a highest performance. Everybody is at the highest performance. Or some people are in between. And you can go on and change the situation. As you make changes, Mathematica automatically makes differences. And you can be able to see what is happening with the performance, the evaluation of the performance of different people. If the performance can change, and it's not at the lowest, but the performance may be different. What do you have? Variations. What do I want to do in the future? I want to teach this class with statistics. That's what I was talking to Gary about. If the performance changes and the performance is increasing, do I have the same evaluation? Do I have the same distribution of people to different cases? If people allow themselves to teach more, to go to their highest, if people can go on and they can do the highest, and you cannot have really decimals, but you can go to the highest. If everybody can go on and teach to the highest, what do I have here? Everybody can teach three classes. So the supply for professors is for 12 classes. I go on to demand for classes. The demand for classes is low. What do I want to do? I want to increase the demand for classes. If the supply is for 12 of professors, I want to get 12 classes. Can I get 12 classes? I can get 4 statistics, and I can get in finance. Now we have a lot, as you change the number, you realize that Mathematica goes on and makes recalculation of everything. So what do I have? 4 and 4, 8. 4 and 4, 8, and 2, 10, and 2, 12. What do I have? The supply and the demand is exactly the same. If the supply and the demand is the same, I don't have excess demand, I don't have excess supply. What is happening to my solution? Anderson is doing 2 statistics. William is doing 2 statistics. I want 4 statistics. I'm satisfying with my statistics class. Anderson is doing 1 management. Smith is doing 3 management. I cover 2 people with management. What is happening with management? I want 4 classes. And I go on to see what is happening else with finance. Williams is teaching finance, Myers is teaching finance. Nobody else is teaching finance. Why? Because I have only 2 classes in finance. What is going to happen if 1 class is not going to be offered? What is going to happen if 1 class is not going to be offered? Then I have 1 class in finance. If I have 1 class in finance, someone is not going to teach it. Finance is going to be 1 class. Who is not going to teach it, and what kind of domino effect is going to change? But if Esther goes on and writes in ratemyprofessor.com and posts that these are great finance classes, and everybody goes on and gives a lot of finance, what is happening if this is the case? And goes to the highest point. We don't have a solution. Why don't we have a solution? Why don't we have a solution? Because we cannot be able to balance what we have with what is happening. And what I would like to see is, I would like you to discuss mainly a few things. First, I would like to discuss the problem. So I would know that you know really what is the problem and how you can control it. And after you know what is the problem and you know how to control it and you have an idea how Mathematica is doing it, I want you to play around and make changes. I would like you to know whenever you solve the problem for the first time, Mathematica is giving you a solution that is useless solution. And this solution is just to start. The only thing you want to do is to see what is happening. What is happening if things are getting better? And as you increase the result, what do you see? You see, you have a difference in allocation of people. But also you have a difference on this number here. What is this number? This is the total amount of all the professors in terms of satisfaction. If you go on to Anderson in statistics, if Smith becomes good in statistics, and Smith becomes even better in statistics than Anderson, cannot. But if Anderson becomes a little bit worse than Smith, if Anderson becomes worse than Smith, at what point Smith and Anderson will have different allocation and they will teach different classes? And this is the dynamic problem that I would like you to explore. And I would like you to be able to present this part with some confidence that you may not have it now, but don't tell it to anybody. I know it and you know it. But you need to present to others that you know what is happening. And as the time is up, I still want to stick to this particular problem because this is a very useful problem. What do? We do mainly make decisions. Who is going to be able to do what? In order to do this decision, we need to understand mainly three pieces of information. What we need to understand? We need to understand their availability. If their availability is different, then the solution is different. And the solution always starts from the lowest point. And if you change the availability, then something is happening. If you want more courses, you have a different solution. I want you to look at the solution and I want to look at the coefficients, but I don't want you to tell me these are coefficients. I want you to tell me what this is in real terms. I can't hear you, Robert.
Thank you, sir. Yes.
And if you do that, I'll tell you something. Nobody in New York is doing it like this, so you are in advance of everybody else. And you can be able to play around and you can see what is happening. And then the next stage is not to tell them, anybody, that you do it with Mathematica, these are the equations, etc. Nobody bothers about that. Why nobody bothers? Because Damien that did it is already promoted. And Damien has Quaco to go on and keep the work for him. And soon he is gonna move up. And I would like to see a presentation that would indicate something that already I know it, that you start getting it and you have some experience about that. And if we can do it, then it's gonna be fine. What do I have? I have 19 people. Minus myself, I have 18 people. We are doing quite fine. Those who are not in class today have to go on and get and see it in a video.
Professor,
Yes, sir.
can you go over the 3 things